guys, today we are back with another problem. The problem of the day is k closest elements. So the k closest elements are elements which has some particular constraints and some particular for things which are given. So the constraint, if the x is present in the array, then it need not to be considered. Okay, if two elements have same difference, the greater element is prioritized. If the sufficient elements are not present on the right side, take elements from the left side and vice versa. Okay. So let's take two examples. Okay. So over here in this, I will just quickly explain that particular problem. So if you just see carefully, what we are going to do is, today's problem is, we are first going to write the problem. Okay. So the problem is k closest elements. Okay. So if you see in the k closest elements, what are the elements we have? So if I want to take an array, say suppose ARR, okay, the array has certain elements, right? The array has certain elements, say 4, 5, 7, 8, 10, 11. Now user will give one value. So inputs will be two values, val1, val2. So val1 basically can be any value from this array. Val1 can be any value from this array, and val2 signifies the total number of closest elements you want. Say for example, I want two closest elements out of this particular val1. So if they give a element, say x equals to val1 equals to 8, then what will be my two closest elements from 8? So if I get 8 over here, I have to take the closest elements. Okay, so while taking the closest element from 8, I can go either this side or I can go either this side. So when I'm looking at this side or this side, first difference is 7 minus 8, which is 1. Okay, so this is the closest, and the next difference is 10, which is 2. Okay, so the two closest elements are 7 and 10. Okay, suppose this value is not 2 and this value is 3, means I have three closest elements. Then while getting three closest elements, what I have already done is I have taken this and this. Okay, now if I want to take this element or this element, I have two options, right? This or this. So in case of this or this, 5 minus 8, the difference will be what? 5 minus 8, the difference will be 3. So first I have to calculate difference equals to 3 in this 5 minus 8 case, and 8 minus 11, 8, 9, 10, 11. The difference will also be 3. Understood? So when we have two elements of the same difference, then what is our constraint? We have to take if the same difference, the greater element is prioritized. So in this particular case, the greater element is either 5 or 11. So 11. So the element will be the three k closest elements will be 7, 10 and 11. Okay, so this was today's problem statement. Now let's go to the code and analyze the code. Okay, so I've already mentioned, I've done this problem, it's a easier one. So what I've done is, first there is a function given as print k closest, which has int arr, n, k and x. Int n is the number of elements of the array, k is the element which is specified, and x is the given element. K is the total number of kth closest element you want, and x is the element which you want to check whether it is closest to x or not. So in case of id1 and id2, there are two things. Okay, so id1, moving backward. So whenever we are moving backward, say if you are in a position over, say whenever you are in a position over here, so whenever you are in this position, whenever you are in this particular position, I told you, right, the index can move either here or here. So while moving backward, we will use recursively, we will call the function crossover. Okay, so while moving backward, what we are doing is we are calling this function find crossover. We are passing the array, we are starting position of the index, we are passing the index 0, n minus 1 is the limit, and x is the thing which we are going. Okay, so in k crossover, there is a low and high. So low and high indexes are starting from 0 and high. So in case of moving backward, we have to call id1. In case of moving to, we will just use the particular index. So say for example, whenever you are over here, whenever you are moving backward, and suppose you are over here, suppose you are in the 7th position and you have moved backward from 8. Okay, So let me just be a bit more clear. 4, 5, 7, 8, 10 and 11. So say for example, this is my main value, and I can move backward, okay, and I can move forward. So when I'm moving backward, I'm calling that function Cray crossover, and I'm over here at this particular point. Now what I can do is I can again have to go forward, right, in order to check the indices. So for moving forward, what I'm doing is id 1 plus 1. So id 1 plus 1 is the one which we are doing for moving forward. If the element present, then we have to neglect. So suppose this condition, if x is present in the array, then it is need not to be considered. So for that we have to neglect it, and we have to go backward by using id minus 1. Okay. Then we are storing the answer array to store those elements or the k closest elements, and k will be the limit of the array, because since the total number of find the closest elements is k, I already told. Now we are traversing through the loop, both pointing at the valid index. This is the condition for valid index. Index has to be greater than 0, index has to be lesser than n. Or you can write less than equals to n minus 1. Okay. Next what we can do is int val1 equals to mat.abs of ar id minus 1x. Okay. What we can do next is a minus, and val2 is mat.avr of. Okay. So what val1 and val2 doing, I have already explained over here. Val1 and val2 does val2 is used for absolute difference. Okay. Next what you can do is val1 uses absolute difference, closest element. For finding the closest element, we are going to check val1 is lesser than val2, which is more closer. Then in the answer array, we are going to store the particular error of id1. Similarly, else if it is more closest, or you have prioritized the greater number, which I have already told. Okay. Then else if condition is there, if it is greater than 0 minus 1, and else id2 plus 1. For finding the closer element, you can see this is some sort of a binary search for finding the crossover. So in this case, what you can also write, similar to binary search. So in binary search, what we can do is, binary search, we take a low value, we point it as 0, we take a high value, we point it as n minus 1, then we put a while loop. Okay, the while loop, you can see I remember this pretty much because I've done this so many times, right? So while loop low less than equals to high I will do. Okay, this is the pseudocode I am writing for binary search. Over here in low less than equals to high, what I'm going to do is I'm going to take a int mid for mid value, and I'm going to do low plus high minus low by 2. Okay, this is the pseudocode I'm writing. After that, once I've taken the mid value, I'm going to check the if condition. If the array is lesser than low, what I'm going to do is left and right, or I can write it left, low equals to, so I can write it like this. If the mid, so if I can write it like this as low less than mid, and the else if I can write high greater than mid. So what you can see is, if you see this particular problem, there is a low and high. If the low is greater than less than equals to x, because in this case we are dealing with x, we will return high. If the low is greater than x, we will return low. Okay. In case of mid, low plus high by 2 I have already written. So the if conditions will be, if the mid is lesser than x and the mid plus 1 is greater than x, we are going to return the mid. If the mid is lesser than x, we are going to recursively call this function and move and traverse ahead. So mid plus 1 high, and these are the elements which we are going to pass in this find crossover, and finally we will find the find crossover function. So this was today's problem. Let's check the problem. Sometimes the internet is slow. It will eventually give me the score. Okay. So I hope you liked today's problem, and we are looking forward to solve more problems. Thank you.